But really, the idea is that we have a radical, and that radical has two parts, right? It has a u and it has an a. So the u is going to be x. The a is going to be the root of 3. And all we do with a trig substitution is we organize our information in a triangle to manufacture that radical. So as long as that's happening, then we're doing it the right way. It's just a question of, how many hoops we're going to have to jump through in order to get the right answer. Right? So I need to place them so that the missing side is going to have a radical x squared minus 3. Well, that's going to mean that the hypotenuse has to be x. One of the two legs, it doesn't matter which, is going to be the radical 3. So I'll just put it here. So the missing side would be x squared, radical x squared minus 3. All right. So again, placement is everything. It might cost you an extra 30 seconds if you place it in the wrong spot. You put the radical 3 where the x is, and you come up with 3 minus the root, root of 3 minus x squared. They're like, oh, that's backwards. Okay, so switch the x in the radical 3 and you get it. All right, so worst case scenario, you zig when you're supposed to zag, so zag. Oh, it's the square root of each of these to give us the u and the a.
U's always aspects.
Yeah, unless it were something like x to the 4th, in which case u would be x squared. I mean, I think as a class, you'd all have to send me hate mail, that would arrive on Monday, in order for something like that to happen on a test, though. So we can assume it's going to be x. I'd have to get 20 pieces of mail, actual handwritten letters describing how much you hate me, in order for me to actually change the problem to be something along those lines. So yeah, you can kind of rely on it being. So now we can get into our substitutions, provided we can come up with what we're supposed to come up with. So ratio of variable to constant So x over root 3. That's the hypotenuse over the opposite side. So that's cosecant. Then we want to do radical over constant. I mean, theoretically, the idea is to get the constant involved in as many ways as possible. And this structurally is how that bears out. Because we know constants are easy to work with. And more often than not, they're going to simplify the problem. All right, so this is adjacent over the opposite. So that's cotangent. Now, you can tweak this if you want. You might say, I don't like cosecant and cotangent. So maybe you move some things around. Maybe you swap your radical x squared minus 3 with your radical 3. And then go from there. I'm fine working with it anyway, so I'm just going to keep going. Oh, sorry, can't just keep going yet. So x equals root 3 times the cosecant of theta. And then, well, this is a little messier than we would like, but not terribly so. Differentiate. So again, for the radical to constant ratio, once you get that solved for the radical, you're done with that. It's substitutable at that point. It's the other part that you have to differentiate. So dx would be equal to, so it's going to be a little messier, radical 3 times, what's the derivative of cosecant? Negative cosecant cotangent. So this is going to be negative root 3 cosecant theta, cotangent theta, d theta. Now you might at this point say, well, I'm going to go back and change this up and swap these two things. But then at this point you get radical free secant theta, and you're still stuck with a secant theta tangent theta. So, it's where there's death, there's always death. It's you're stuck with it. Movie reference? That one was much more obscure. How about this? Pi don't work unless you let it. I gotta say it like you said. Pi don't work unless you let it.
Gotta be
Nah. I try to go gravelly with the voice. A little bit of a southern drawl, but
The actor is it Matthew McConaughey?
no.
Was it like a pretty movie?
No, it's a light comedy. Honestly, I'll be shocked if anybody gets this one.
Oh wait, I got it. It's with Martin Lawrence and Eddie Murphy.
I'm trying to think of a movie with Martin Lawrence and Eddie Murphy. Wait a minute.
That movie, Harlem Nights or something like that. No, when they get locked up and they get sent down to the South and he steals a pie. One of the prisoners steals a pie. And,
That sounds like Oh Brother, Where Art Thou? And that didn't have either of those in there. That would have George Clooney.
Martin Lawrence and Eddie Murphy in that.
Martin Lawrence and Will Smith were in like Bad Boys and things like that,
No, they weren't. But it was a really good movie. They one of them, they get locked up together basically, and they're trying to escape from. They spend the next 20 years trying to escape. It was.
Oh, are you talking about? Oh, I know what you're talking about. And then they make a break for the border. Not
Like the end of
the Federales. Blue Streak. Blue Streak. Yeah, but that's what I was thinking about because he did a jewelry heist and he hid the diamonds. And then he goes to jail. He comes back and they built the police station over it. Yeah. Yeah. That's an obscure reference. Oh, I can't. Dave Chappelle was in that too. Was that
Live.
live?
You never watched Live?
No, you got me on one.
It's came out in 1999.
Oh, that's in my wheelhouse. I should have known that one.
Bernie Mac is in it.
Oh, Bernie. Oh, okay.
Oh yeah, Bernie.
Oh, Bernie Mac.
One of the movies.
Yeah. Oh, okay. I'll have to take a look at it.
So since I stumped you, I get a 1999.
Yeah, you still haven't answered mine.
I don't work with it.
So anyway, Will Smith was in that movie. So I'm replacing the root of x squared minus 3 with the root 3 cotangent of x, cotangent of theta, sorry. And now I have to swap out this dx for that other fun stuff. But there's a little twist in this one, so that's why I'm doing it kind of piecemeal here. I almost wrote the wrong thing. So I got that X on the bottom. It's just kind of staring me in the face.
Man in Black.
Which one?
First one.
Third one. Yeah. Well, that's because I'm looking at this as what X is equal to. So I'm going to do that sub in. Actor? Josh Brolin.
Oh, the young one?
The young, yep, young K. All right, so by subbing out the x for what it is, and it was kind of hidden in there, when you did your substitutions, it got a little messy, and then you might end up staring at this for a while, figuring that you did something wrong. But no, there's a way to substitute that out also because we have a relation between x and theta. So make that substitution, then start your cancellations. So boom, boom, boom. I'll boom that one with this boom. And then we will have negative cotangent squared theta d theta. Radical 3, yes. Oh, I'll just, yeah, there's no fixing it. I'll just erase it. I was going to just chuck it in the front, but then it would look weird. So then, what? Right, so we have a cotangent squared. Now, if I had like a cosecant squared or a secant squared, I could easily find the antiderivative of that by rule. But a cotangent squared, to the best of my knowledge, we don't have a rule for that. All right? So we're going to want to morph this a little bit. I'll put the negative radical 3 outside. That's the same as cosine squared theta over sine squared theta. Because you get to this point in the process and you say, well, the idea is not that you're grasping at straws, but you're looking for something that would be helpful. And hopefully, I mean, I don't know too many people that look at cotangent squared and think convenience when they see that. You know an awful lot about sines and cosines, so let's live in the world with sines and cosines for a few minutes and see where that takes us. All right. Now, I don't have a u that I could define here. I can't just say u is equal to sine squared because that's not going to cancel the cosine squared. But maybe there's a trig identity that I can apply. Do we know what cosine squared is equivalent to? One minus sine squared. All right, so let's pull on this thread here and see where it takes us. Well, we have a minus. Break it up, right? Break it up into two separate fractions, 1 over sine squared minus sine squared over sine squared, which is the same as saying 1. All right. A little bit further. One over sine squared is the same as cosecant squared. Now, I just got through saying that when we're in the world of cotangent, we don't think of that as convenient. So why not go in terms of sines and cosines? Then once I got to this, I'm flipping it back to cosecant squared. There was a reason for that, and it's a good reason. I didn't have a rule for cotangent squared, but I do have a rule involving cosecant squared. Right. So what I'm going to do here is I'm going to bring this negative back in. I'm going to write it as radical 3 in the front, negative cosecant squared theta plus 1 d theta. Because I do know the antiderivative of this, and that is what? Well, let's say if it were secant squared, what would its antiderivative be? Cotangent of theta, yeah. And that's the reason why I brought the negative back in, because I'll put all the bells and whistles in here too. That's the reason why I brought the negative back in, because the antiderivative of negative cosecant squared is your cotangent function. You could leave it as cosecant squared and write negative cotangent, but then you're just going to negate it anyway. So I leave it up to you. I mean, I leave a lot of stuff up to you. But in that case, it's a matter of preference. And also, you get a completely different answer if you opted to organize your triangle slightly differently. And by the way, I'm going to snag this and bring it down because I need to reference it. Question? Yeah. Here? This one?
I can make cosine minus 1 right here.
Here?
That's squared. Cosecant squared minus 1.
Oh, yeah, you could do that substitution, sure.
I can do it right here.
Yeah, I just never have faith that anybody would know to do that. So, the 75 or so times that I've led with that, the blank stares that greeted me, they're the loudest blank stares ever. Like they form a spotlight that burns a hole through my flesh, and so I always end up going through it this way. Yeah, if you see it, go for it. Yeah, always. All right. So now back to the triangle, because I can't leave it in terms of theta. And we know we can't leave it in terms of theta, not because I'm just telling you right now, but because the original question was in terms of x. We only converted it in terms of theta for our own convenience. So we used theta for what we needed it for. Now it's time to go back to x's. Cotangent is adjacent over opposite. Theta, you have a lot of different options here. I mean, you could look at this and say, I'll just work with the triangle the way it is and just pick out a ratio that I like. We already designated a ratio above, but I don't want to scroll back. So I'll take the one that we did designate above, and that was cotangent of theta is equal to the hypotenuse, I'm sorry, not cotangent of theta, cosecant of theta is equal to hypotenuse over opposite. And then take the inverse cosecant of both sides. And you get theta is equal to the arc cosecant of x over root 3. Again, choose whatever ratio you like. Does not matter to me. If you want to go with the sine function, go with the sine function. I only grabbed this one because, well, I could be wrong, but I'm pretty sure that's the one that we wrote above. But I could have did sine of theta is equal to root 3 over x. And so we would have the arc sine of root 3 over x. A lot of different possibilities. In fact, 6 completely unique possibilities based off of that triangle. And again, if we placed these two, if I put my radical 3 down here, and therefore cause this radical x squared minus 3 to go here, completely different ballgame. Right? And again, just going back to the boundaries of integration, since I've been repeatedly telling you that you would just pop it into the calculator anyway, I would not expect you to take this and then plug in the radical 3 and the 2. On the test, if you see a question like this, you go to math, option 9, and put this in exactly how you see it, hit enter, and then write down everything you see on your calculator. If it's an ugly decimal, give me the whole shebang, and then call it a day. You know, don't overthink it. It's supposed to be a gift. All right?